looking at using the tangent function to find a side of a right triangle. But first of all, we need to remember a name, and that name is, and we spell SOHCAHTOA. And S stands for sine, O for opposite, and H for hypotenuse. C stands for, A is, and H is, oh, well, that's unfortunate. Okay. H is hypotenuse again. T for tangent. So we're going to use all three of these coming up soon. So we're not going to be working with just tangent. You're going to have to determine which one of these to use. And this is the key to knowing. O is opposite again, and A is still adjacent. So that gives us the definition of the three trigonometric ratios, the three main ones. So let's look at a problem involving tangent again. We have a nice right triangle here, and we have a 28-degree angle. And let's say that this is x and 14. Yes? I don't know. Yeah, I guess so. So what's the equation that goes with this? First of all, we see that in relation to the 28-degree angle, the two sides we're working with are the opposite, the x there, and the adjacent, the 14. So opposite and adjacent, that tells us that we're going to use opposite and adjacent goes with tangent. Okay, because today we're going to have to start making those decisions. We haven't had to because all we've used was tangent up until now. So we have the tangent of 28 degrees. Remember that what comes after the tangent, sine or cosine, is always the angle measure. Equals, by our definition, the opposite, x, over the adjacent, 14. So now we have this equation that needs solved. And we first turn it into a proportion by putting that over 1. And then, since it's a proportion, we can cross multiply. So the 14 times tangent 28. Remembering that tangent 28 is a number. I just don't happen to know what that number is. Equals, and the 1 times x is just x. James. There are two reasons I'm doing it this way, instead of just putting the 14 on the other side. The first reason is, on the first day when we were looking at this, people were very confused by the idea of this being x divided by 14, and so you multiplied both sides by 14 to solve. So if you see that, you're okay to do that. There's nothing wrong with it. The second reason that I'm doing it this way, though, is because when the x is in the denominator, for other problems, you can't just do that. And so it saves confusion there, I think. So while it certainly is something you can do, not the way I'm teaching it right now, but you're welcome to do that. Now we grab the calculator. I did. Now we grab the calculator and work out 14 times tangent 28, making sure, of course, that you're in degrees mode if you haven't checked that lately. Okay, so multiplying that, you should get that x equals 7.4. And unless otherwise stated otherwise, we usually find angle or side lengths to the nearest tenth. round those off to the nearest tenth is good. Okay, let's do one more of the other type before we move on to the new ones. So we have an angle 20 degrees and 4 and x. So for this one, once again, we look at the angle first, and we see in relation to that angle, we know the opposite side, and we're trying to find the adjacent side. Opposite and adjacent. Adjacent cannot be the hypotenuse. So opposite and adjacent means we're going to use tangent. So the tangent of 20 degrees is opposite 4 over adjacent x. So here, James, is where you can't just do that shortcut. And so here we put this over 1, we cross multiply, we got a little bit more algebra to do here. So we get x times the tangent of 20 degrees equals 4. Now remember that the tangent of 20 is just a number. So if you have a number times a variable, you solve by dividing by that number. So we're going to divide by the tangent of 20 degrees. Those will cancel out. We have x equals 4 divided by the tangent of 20. Grab your calculator and work that out. Okay, and we should get that x equals 11. Now rounded to the nearest tenth, what is it? 11.0. Because if it says to the nearest tenth, you have to record so that we know that is accurate to the nearest tenth. If you just write down 11, I don't know if it's accurate to the nearest tenth or not. Yes, Logan? Depends on the mood I'm in when I'm grading, if it would be points off the test or not. Okay, so now we're going to take a look at how to do this with sine and cosine. So sine first. So if we have a triangle, and this time in our right triangle, we have a 50-degree angle here. And we want to find this side, and we know the hypotenuse is 12. So the first thing is determine, is it sine, cosine, or tangent? And that's based off those definitions that we have from SOHCAHTOA. So we look at this angle. In relation to that angle, I'm trying to find which side. The opposite side. The side that I know is the hypotenuse. So as soon as I see opposite and hypotenuse, I know those go with sine. And so I'm going to use the sine this time. The sine, always the angle after sine, cosine, or tangent of 50 degrees is, and according to our definition, sine is the opposite, which is opposite. What's our opposite side? X over the hypotenuse, which is 12. So there's our equation. From there, there's nothing really different than what we did with tangent, except you're going to push a different button on your calculator. So if we take that, put the sine 50 over 1 again, cross multiply. So we have 12 times the sine of 50 equals x. Nothing else we have to do there but grab the calculator. I should be doing that, and I do that mainly because your calculator does. And remember to always put that closing parenthesis on there to avoid some potential errors. Sometimes it will do it right if you don't do that. Sometimes it will not. So work that out. And we get that x is 9 point what? 9.2. We agree. Okay, so that is using sine when we're looking for the opposite side. So our variable ended up being in the numerator of the fraction. If we're looking for the hypotenuse, let's call that h for hypotenuse. Once again, we start off by looking and saying, oh, here's the 15-degree angle. In relation to that angle, I know the opposite side. I want to find the hypotenuse. So opposite and hypotenuse means I'm going to use sine. Then we have, by our definition, sine of what? 15 degrees equals 12 over h, because it's opposite over hypotenuse. Sine, how did we define it? Sine is opposite over hypotenuse every time. Now we can make it the proportion. Cross multiply. H times the sine of 15 is 12. Next step is divide by the sine of 15 on each side. Sine 15 cancels. H is 12 divided by the sine of 15, which is approximately 46.4. You should, yes. I think I haven't been doing that today.